This video is over Lesson 98, Relations and Functions, and is for my pre-algebra classes. A relation is a pairing of two sets of data. And so that those two sets of data can be all kinds of things. It could be your name with your phone number, like the phone book. It could be your name with your birthday. It could be your height and your weight. So a relation is just two sets of data where you have an input set that results in an output set. So once again, your name and your birthday. If I input your name, I can output what day you were born. Now, most typically, we see that as X being our input and Y being our output. A function is a special type of relation. A function is a relation where every input has exactly one output. Exactly one output. So testing for functions. We can see relations represented all kinds of different ways, sometimes in a table of values, sometimes in an equation, sometimes in a graph, sometimes in various different diagrams, sometimes as sets of points. So we're going to take a look specifically at a table of values and at graphs. So testing for functions. I want to know if a relation is a function. So in a table of values, we want to check to see if any input results in more than one output. If yes, it is not a function. If no, it is a function. So you need to think of this more as an elimination test. If you can find any place where an input results in more than one output, it is eliminated as a function. So I've set up three tables of values down here. And they're just short. We're just going to get the idea here. So first of all, my first table of values, we're looking at the inputs, 2, 3, 4, 5. So since all the inputs are different, this is pretty good. So all inputs are different. So, well, if they're all different, then is there any place where 2 is coming out with something more than 6? Or where 3 is coming out with something other than 9? No. So all inputs are different, so it is a function. There's nowhere where I can find an input that results in more than one output, because each input's just in there once. Now over here, you'll see I have the input 2 that has been used twice. So is this a function? Well, again, we're checking to see if any input results in more than one output. Well, here when I input 2, I output 6. Here when I input 2, I still output 6. So here, my repeated input results in the same output. So it is a function. That's okay. It's okay to have a repeated input as long as it's still producing the same output. Think about it this way. If we go back to the name and the birthday, if I input your name, I want to know that your birthday is coming out. But if I put your name in once and I get a birthday out, then I'm going to expect that if I put your name in again, I'm going to get the same birthday out. So that's okay. As long as that repeated input gives me the same value again, that's fine. So if we look at the last example, again, 2 is a repeated input. I have the input 2 in both places. Here when I put in 2, I get out 6, but here when I put in 2, I get out 24. Going back to your name and birthday example, well, if I put your name in, and find out that you were born on January 1st, and I put your name in again and it says July 14th, well, then I don't know which one's accurate. I can't depend on that. And so this would not be a function. Now, there are relations out there that are not functions, and that can be okay in certain circumstances, but they're just not functions. So this would not be a function. So this time, my repeated input resulted, well, let's be consistent with the language here, results in different outputs. So it is not a function. So again, if there's any place where we can find an input that results in more than one output, so 6 is one of the outputs, 24 is another output, that has more than one output that comes from 2. So not a function. So that's the idea when we're looking at a table of values. So now let's talk about on a graph. So on a graph, we use what's called the vertical line test. The vertical line test. The vertical line test says if a vertical line can be drawn anywhere on the graph such that it intersects, so intersects, touches, goes through, it intersects the graph more than once, then the relation is not a function. So again, this is an elimination test. So if I consider, I'm just going to make some sketches here. If I consider a graph that maybe comes through a little bit like this, the vertical line test then is saying, all right, if I send a vertical line through, vertical line through, vertical line through, vertical line through, vertical line, vertical line, vertical line, vertical line, is there anywhere where I can draw a vertical line where it hits more than once? Well, no. So this actually would be a function. Let's say I have a graph that looks like this. Well, vertical line, vertical line, vertical line, vertical line, vertical line, vertical line. Nowhere there. Now over here, it doesn't hit at all. That's okay. We're just looking for anywhere where it hits more than once. So it can hit not at all. It can hit once, it just can't hit more than once. So this actually would be a function. If we consider one more graph here, let's say this time we have a graph that looks like that. If I send a vertical line through here, it hits there and it hits there. This would not be a function because a vertical line can be drawn. It just takes one to eliminate that as a function. That is a vertical line that hits the graph more than once, not a function. So if we flip our papers over, please, and on the back, we're going to do the practice problems from this lesson. Just 4 of them. And that is on page 654. 654. And it says, for A through D, state whether each graph or table is a function. So on A, I'm just going to do a quick sketch of it here on my paper. So it looks something kind of like that approximately. So as I look through this, is there any place where I can draw a vertical line where it's going to hit that graph more than once? Well, no. And so what that means, remember, this is an elimination test. So by saying no, that means I cannot eliminate it as a function. So if I can't eliminate it, it means that, yes, it is a function. So remember that these tests are elimination tests. So if you can say yes to the test, it's not a function. If you can say no to the test, then it is a function. That's A. B, likewise, I'm going to sketch that real quick. And so B looks like it's coming through, kind of curves there and comes about there. More or less like that. It's close enough. So is there anywhere here where we can draw a vertical line where it's going to hit the graph more than once? Well, yes. It hits there and it hits there. That's more than once. So that means if we can say yes to the test, that means it is eliminated as a function. So if it's eliminated, then no, this is not a function. All right, for C, I'm going to go ahead and copy the table down. So I've got X, I've got Y. You don't have to turn this into a big box. We just kind of make a T or a cross there, that's good enough. And there are 5 inputs, 3, 2, 1, 2, 3. And I've got outputs 5, 6, 7, 8, 9. So remember, for a table, we're looking for any place where a repeated input, so some input, results in more than one output. Well, if I look at this here, I notice that 3 has been repeated. So since 3 has been repeated, does it come out with the same thing? Well, when I put this 3 in, I get a 5, but when I put in that 3, I get a 9. So no, this is not a function. And why? Right there. You can't put 3 in and get out 2 different outputs. There should be exactly 1 output. So that means every time I put in a 3, I should get out a 5. Or every time I put a 3, I should get out a 9, but I shouldn't get out both of them. Likewise, we also could have eliminated it because we've got these repeated 2's. If I put in a 2 here, I get out a 6, but I put in a 2 here, I get out an 8. So there are actually a couple different ways that we could eliminate that as a function. It's still a relation, it's just not a function. And finally, D. So X and Y, and there are 3 pairs of values this time. So 2, 3, 4, and then 5, 4, 5. So is this a function? So remember, we're looking for any input that results in more than one output. So 2 results in 5, 3 results in 4, 4 results in 5. Are there any of these inputs that result in more than one thing? No, they don't. So 2 only results in a 5. There's nowhere else where a 2 results in a 3, or 2 results in 7, or 2 results in 8. You plug in a 2, you get out a 5. Now the thing that will trip up a lot of students is the fact that we have double 5s in the output. That doesn't matter. The first place you're looking is at the inputs, and you're looking for any repeated inputs. So if there's a repeated input, does it come back out with something different? Okay. So if we go back to the example of names and birthdays, this actually would still be a function. But it's possible that you could have one person who has a birthday and a different person who has the same birthday. That's okay. In fact, most of the time when we have twins in class, that's what results. Every once in a while, you've got two people who are completely unrelated who happen to have the same birthday. So, inputs, two different inputs can have the same output, no problem. But the same input needs to have the same output. So this down here is a yes, that is a function. And that, ladies and gentlemen, is the end of our lesson.